And coming to the flood forecasting, it is not a data-driven model. Okay, or landslide early warning also. Time is the parameter. So how AI can give the solution for that? Anybody, any panelist or anybody from the audience can answer this. This is my question.
Sir, this is Nikhilesh.
Please, Nikhilesh, please.
So we have been doing AI-based flood early warning system almost now 5 years, sir. So I think you are differentiating between Gen AI and AI. I just want to differentiate. So deep neural network with LSTM and conv LSTM is perfectly working, where we have been able to achieve more than 90%, I would say, success rate, sometimes better than the simulations model. And we had trained over the last 50 plus years of rain, observed, and we have created a semi conv LSTM and I would say data-driven side, physics-driven side model. And Godavari we are doing for Kaleshwaram and other areas of interest. And what we have seen is, sir, if you have long horizon data sets historic, which basically captures, like you said, the next flood could be based on a different event-driven parameters versus what was last time. So how come, if you're able to capture these different variations of events, and the long horizon data sets do have spread of these events, your model would be able to do a better forecast. However, Gen AI side, sir, I think Gen AI is not yet in that format where geointelligence physics is inbuilt into it. So it will do a lot of hallucinations and a lot of wrong, I would say, outputs.
Thank you, Nikhilesh. I know that Vassar Labs are doing a lot of works in hydrological modeling, flood forecasting. So whatever you're saying that you have developed these algorithms, standalone algorithms, or you have integrated with your hex softwares?
We have done hybrid, sir, both. Okay. So hydrologic responses are also fed into the conv LSTM models along with direct parameters like rain. So it's a fused model, physics plus conv LSTM.
So definitely I will visit your office in Hyderabad. Thank you very much.
Yes, please. Thank you, sir. Good evening, everyone. I'm Nikhilesh. So Vassar Lab is a 10-year-old company, and we are focusing on taking data and science to users' hand, predominantly in climate vertical. And we are focusing on water, disaster, agriculture, and forest. And while we are doing that, over the last 10 years, we have built a platform which will create some of the words that have been used, whether it is a sensor-based data, so IoT stack, big data to bring all the data as a fusion together, and then bring remote sensing, AI, ML, and also some of the things that we discussed today. It needs to be real-time, so automation pipelines. And I'll just walk through some of the use cases that we have done in disaster predominantly. And this is one of the product, which is weather monitoring, which is seamless weather monitoring. And we saw weather is one of the most important when we talk about disaster, whether it is cyclone, heat, or flood, or any other thing. Bringing the weather in a holistic manner is very important. You got one agency, IMD, bringing stations which are observed data sets. Then you have state, which is bringing a lot of AWS and ARG stations. And then you have nowcasting happening. Then you have multi-agencies who are doing also on the forecasting, which is short, mid, and long horizon. So what we have done is we have brought all of them with huge amount of data processing. And some of the data processing in Nowcast is happening at every 10 minutes from remote sensing, bringing cloud top temperature, and then more than 70 radar stations across the country we are ingesting every 15 minutes, running AI ML on it and creating a Nowcast product, and then seamlessly merging at every hourly weather station data. So we'll just play a video to show that.
Nowcasting techniques enhance predictions by providing short-term, localized weather updates using radar data, EUMETSAT, and cloud top temperature to understand the spatial rainfall intensification at sub-hourly intervals, which is very crucial to forecast river flow and riverside early urban flood warning and mitigation. It can be used for both flat and terrain undulated urban cities to understand the historic, nowcast, and short-range forecast rainfall intensities with detailed damage assessment.
In order to understand the rainfall patterns from last 3 days to next 3 days, Seamless Rainfall module has been enabled by using 1 hourly observed rainfall, nowcast, and 3 hourly forecasted rainfall. Like the nowcast module, user can seamlessly drill down the rainfall patterns over any region of interest, including all administrative.
So we're working with more than seven state governments and many cities, and also at central government, wherein these solutions are either going further to the flood forecasting model, which is this slide I'm showing, or is also going to the command centers where people sitting is able to understand the intensity of the rain in a usable format, per hour, what is the volume that will come in a particular basin. This is a visual clip from our Tamil Nadu implementations, where more than 13 basins are automated for weather-based flood forecasting, where every point of interest is being measured, and those IoT sensor data are feeding the models, which are hydrologic and hydrodynamic, and creating a hydrologic responses at individual point of interest in the rivers. And a very user-friendly interface that you can see is some of them sensors are having red beacon, which is basically alerting there is a flood in the next 3 days. You click on it, you get to see a heat map, which is telling, hey, how wide the flood is. So that's bringing you the weather story of it. You click further and you see the gauge and the time series of it. Next. Then we translate these data sets into now hydrodynamically. So at a river scale, doing the forecasting, bringing ensemble uncertainty, we are using 51 ensemble runs, and all of these are happening in automations. With every 3 hours, the models updating with the latest data sets, which are coming from forecasting agencies and also ground data, which is coming from sensors. And these hydrologic models are presented into simple GIS. Next. Then at a city scale, so river scale, then city scale. So what now you are seeing is a place in Kerala where Periyar Basin we got a work to do, and as a part of that, few cities were vulnerable. So we had created, using high resolution DEM, 0.5 meter DEM. And what you're seeing is, using again AI, we created the building footprints, the roads, all the channels, and you see some colors and representation. And on the right hand side, you're seeing population impacted, number of houses impacted, road length impacted. At the bottom, you're seeing is a time bar, which is also showing you a peak. You see color red representing which are the hours where majority of the houses are getting inundated. You zoom in and you now can go and see individual asset areas. So let's say airport, I would like to show you. So in this case, now you are seeing a zoomed in view near to this is Cochin airport actually, and simulating a scenario which actually had happened. And you see some colors are getting red, which are basically which are the roads approaching the airport getting red. Red means you cannot now use it. And this is based on depth of the inundation. So time-wise, location-wise, asset-wise, population-wise, so that the alert can be given to the people who are impacted, houses that are impacted. Alert also can be given to the public assets like airport and others and roads where their impact is happening. Next. This is another visual where we zoom into a village area where, again, very simple animation. And these animations are all web-based. These are web-based systems accessed by anybody with login. And you can see how as the water bulge out and in, you have different exposures to different buildings. Next. And then we zoom in further to very critical assets. And this is again a web-based 3D using high-resolution DEM data to understand how the water will approach to an important facility and which area is vulnerable. And then if you want to do mitigation measures, so how can you do a levee or different structures? And these simulations are happening in the web on the fly for a user to be able to understand what kind of first risk, exposures, and then structures that can be added. Next. Some other works that we have done using remote sensing is drought predictions, which is again governed by drought manual, and we have automated that for state of AP where various indicators are done. Another important one, which is forest fire, and what we have done is making use of remote sensing, created two things we have done. We have created a pipeline of remote sensing data sets, which is bringing informations on what is the fire load, what are the species that are there in that area. Then we merge the DEM data and dynamic wind data, dynamic temperature data, and create forest fire spread simulation model. And this can be done at a very, very large area. This was done for few areas in Australia. And similarly in India, it can be done at any scale, where models can be created and set into automation pipeline for telling how if a forest fire is happening, how will it spread, so that sacrificial measures and water measures can be taken up. Next. These are some of the solutions. So we deployed a holistic disaster information and management system in AP, which included right from heat wave to cyclone to cold wave to flood to all the disaster that a state would have. So one unified system for all disasters. Similarly, we have done a couple of other solutions in Kerala, in Telangana, in Odisha.
So we've passed 10 minutes also.
Next.
Nikhilesh,
I just want to, last one, sorry, sir.
we'll have to minus 5
Yeah.
minutes.
Last one. So I just want to add here, since the beginning, one of the topic was open source, and a lot of questions were asked about whether it can be done or not. I would just like to highlight that we saw that there was a gap, and to address this gap, the entire solution that you just saw is a glimpse of very few among what we are doing, is all based on open source technology. And of course, you cannot use open source directly, so we have actually built it to make it usable by customers. Also, these solutions are in existence for more than 7 to 8 years in some of the states, sustainably running. In some of the places, we have finished the contract and it is running sustainably. So I'll just pause here, and thanks a lot for giving the opportunity.
Thank you. Now we'll go to Galaxy, Mr. Devjyoti Pal, and for your comments on what has been said and if anything you wish to add.
Yeah.
And so you must be smiling after this conversation that it's only your business that the big businesses in India want, the analytics.
Well, I'll be happy. But yeah, I think the point is the GIS world, which was predominantly, if you see, 20 years before, was primarily a tool for planners and designers. And perhaps the use case was one time in nature. But today, given the climate change scenario, and also the urbanization, I would put, as the disaster has closed in more frequently and also more intensely, the need to monitor in real time is very, very high. The user story has shifted from once in a time of design to keep watching it. And as it is on keep watching, that's what is driving the satellite need. That's what is driving the need to have different types of satellite, right from optical to hyperspectral to SAR, and also different products derived out of it. And it needs to go also to now new user groups. So it needs to go to the actions taker. It needs to go to the State Department first line responders. It also needs to go to the individual citizens. Because today when we talk about floods, a very controversial subject, that what is a flood plain? And are we encroaching into the space of water rather than water reaching us? So I think it needs to go everywhere where a risk assessment is dynamically done, but also early warning and action to be taken is in the hands of the responders and also stakeholders.
Okay, great. Thank you. So that's very interesting all through. So are there any futuristic points you want to make?